it's time to give type 3 for indeterminate case, for indeterminate forms of limits. What will happen if we have infinity over infinity to the power 0, 0 to the power 0, and 1 to the power infinity? In limit expressions, what will happen if we have one of this case? Let's try to understand by an example. Example 1. Limit of x to the power 1 over x. X tends to infinity here. So when x tends to infinity, the base tends to infinity and the power tends to 0. So you have type 3 indeterminate form. Of course, it's not possible to directly apply L'Hopital's rule, so we have another way to solve this kind of questions. The way is that you first give a name to the given function, let's say y. Since it's a function, let's say y is equal to x to the power 1 over x, okay? And take the ln of both sides. Ln of both sides, ln of left hand side is ln y is equal to, using the properties of ln, you have 1 over x times ln x, right? Since ln a to the power b is equal to b times ln a. Okay? So we have this equality. Instead of looking at the limit of left hand side, we focus on the limit of right hand side. So let's look at the limit of right hand side. Limit ln x over x, ln x over x, when x tends to infinity. Do you remember this question? When x tends to infinity, you have infinity over infinity. Of course, you can apply L'Hopital's rule here. If you apply L'Hopital's rule, derivative of ln x is 1 over x, derivative of denominator is 1, so the answer is equal to 0, of course, right? Derivative of, you finally have 1 over x here. When denominator tends to infinity, then the expression goes to 0. So the answer of left hand side of this equality goes to 0. Okay? It means ln y also goes to 0, right? ln y goes to 0. ln y goes to 0. So what is the question? What do we look for? What about y, right? Since the function is y, not ln y. When ln y tends to infinity, if you take exponential of both sides, what do you have? E to the power ln y, which is y, goes to e to the power 0, which is 1, right? I take the e to the power, e of each sides, exponential of each sides. Then you have y here, then you have 1 here. Do not forget that the function was y. So the answer is 1. It is the way. Let's look at another example. Example 2. X to the power x. I slightly change the question when x tends to 0 from right. If you look at this question, you see that you have 0 to the power 0 type 3, right? It is also type 3. So you say that y is equal to the function x to the x, x to the power x. Take the ln of each sides. using the properties of ln, you have x times ln x. Instead of looking the limit of left hand side, we are looking the limit of right hand side. I need some space. Limit x tends to 0 from right, x times ln x. When x tends to 0, it is 0. And this expression, when x tends to 0 from right, then ln x, if you remember the graph of ln function, ln x tends to minus infinity, right? So let me slightly change this expression. It's possible to write this limit function as ln x divided by 1 over x. X is still going to 0 from right. In this case, when x tends to 0, you have infinity over infinity, right? You have infinity over infinity. So it means you can apply L'Hopital's rule now. If you apply L'Hopital's rule, derivative of numerator is 1 over x and derivative of denominator is 1 over x square minus 1 over x square, right? So if you substitute this expression, you see that you have limit of x. Actually, you have minus here and x tends to 0 from right. Again, you have 0, right? You have 0. Since right hand side of this equality goes to 0, okay, ln y also goes to 0. When ln y goes to 0, y goes to e to the power 0, which is 1. The answer is the same. The answer is 1. Okay, let me now solve a different kind of type 3 problem. Let's say we have this limit 1 plus x to the power 1 over x. Here x goes to 0. Okay, let's first look at this function. When x goes to 0, inside goes to 1, right? And the power goes to infinity. So you have 1 to the power infinity type 3 indeterminate case. So what is the first step? The first step is to give a name to the given function. Let's say y is equal to 1 plus x to the power 1 over x, right? And ln y is equal to ln of right hand side 1 over x times ln of 1 plus x, right? Instead of focusing the limit of left hand side, we focus on the limit of right hand side. So let's look at the limit of right hand side when x tends to 0. So you have a division here, right? You have a division ln 1 plus x divided by x. When x tends to 0, you have ln 1 in numerator, which is 0. You have 0 in denominator, so you have 0 over 0 case. 0 over 0 case. So since we have 0 over 0 case, we can apply L'Hopital's rule. This expression is equal to limit x tends to 0, derivative of numerator is equal to derivative of inside over inside, 1 over inside. Derivative of denominator is 1, right? When x tends to 0, you have 1 as a result. Let's go back to the function again. Let's go back to this equality or this equality. Okay, let's say this equality. Since right hand side goes to 1, ln y also goes to 1 when x goes to 0, right? What about y? when ln y goes to 1, if you take the exponential of both hand sides, you see that e to the power ln y, which is y, goes to e to the power 1. So the result is e, the number e, exponential number. You may expand the scope of these questions. Let me solve another type 3 question here. And I want to give the idea actually. Let's say you have limit when x tends to 0 from right. One plus sine 7x to the power cotangent 5x. Okay? If you look at this expression, you see that inside of the parentheses goes to 1, since sine goes to 0. So you have 1 to the power, and cotangent 5x goes to infinity. If you remember the formula, you see that you have infinity in the power. So you have 1 to the power type 3 indeterminate case. So the first step is to give a name to the function, right? Let's say you have y for 1 plus sine 7x to the power cotangent 5x, right? Then you take the exponential, you take ln of both sides. ln y is equal to cotangent 5x times ln of 1 plus sine 7x. Sine 7x. Again, instead of looking the limit of left hand side, we look the limit of right hand side. So when x tends to 0 from right. I don't want to go to details again, but if you go further, you will see that the result of this limit is e to the power 7 over 5. Okay? It is the idea. I only want to give the idea. Another example, limit when x tends to infinity, x plus 1 divided by x plus 2 to the power x. When x tends to infinity, you see that this expression goes to 1 and the power goes to infinity. So you have 1 to the power infinity type 3 indeterminate case. So you have the same idea actually. If you use the same procedure, you will see that the answer is e to the power minus 1. I strongly suggest you that please solve many problems about especially type 2 and type 3, since it's not so easy to understand or to solve this kind of limit questions. Sometimes they are really difficult. I think it's enough for the time being. Have a good day.